All right. Hello, everybody, and greetings from the Delta College Planetarium. My name is Brian, and tonight we're going to do a whole celebration about Apollo 14. I am joined by Planetarium Manager Mike Murray, who is going to be sifting through your comments as we go through our program tonight. And this is a pretty big event for us. Right? We are right smack in the middle of the 50th anniversary of the Apollo 14 mission. It launched on January 31st, 1971, and it landed on the moon in on February 5th of 1971. So just about 50 years ago tomorrow. Uh, so let's first answer some pressing questions uh, like who are we and what are we doing here? So we are from the Delta College Planetarium in downtown Bay City. If you haven't seen us yet, we normally do public and school shows during this time of year. We have a 50-foot dome theater where we get to explore the universe, but of course, the whole pandemic has kind of put a pause on that for the time being. So we've been trying to explore and continue to explore novel ways to share the planetarium experience. And this sort of live program is one of the ways that we're trying to do that. And this is kind of a continuation of one of the programs that we've been running for the last couple of years. We've been trying to follow the Apollo 50th anniversaries as they come through. We Before COVID, we were in the middle of this year's long celebration. Mike and I are both huge Apollo nuts, and I think that the Apollo moon landings are one of the definitive achievements of the human species and one of the most inspiring accomplishments. So we've been following along in real time on this 50-year delay. It started back in October of 2018 with some social media posts about the Apollo 7 launch. And it was followed up by live programs in the Dome Theater for Apollos 8, 11, and 12. Last April, we had intended to hold another live event for Apollo 13, except that didn't happen. So now we're trying for this live streaming event for Apollo 14. Only the Apollo 14 story really starts with Apollo 13. So you're kind of getting this 2-for-1 event. I'm going to have to talk about both Apollo 13 and 14. And we've got a lot of ground to cover. So let's get started. Imagine that you had been working towards a particular goal for a long time and you've been working pretty intensely for it, but then something totally out of your control upended your plans. And suddenly the thing that you had planned on doing was just totally unworkable. And you had to very quickly salvage anything you could just so you could get through this new challenge facing you. I know it's a totally alien feeling to each of us now, right? So the early Apollo missions focused on getting the basics right. Apollo 7 and 9 proved that the spacecraft could fly in space. Apollo 8 and 10 showed that the spacecraft could make it all the way to the moon and back safely. Apollo 11 proved that NASA could actually land somebody on the moon and return them safely to the Earth. But Armstrong and Aldrin landed miles off target. Apollo 12 with Pete Conrad and Al Bean showed that Apollo could land precisely where scientists wanted to explore. And Apollo 13 was intended to extend that capability further. Not only would Apollo 13 perform a pinpoint landing like Apollo 12 did, it was going to do it someplace geologically interesting. Apollo 11 and 12 landed in the Mare, the dark plains of cooled lava on the face of the moon, and they were relatively clear and level. Apollo 13 was going to land on the highlands for the first time. When you look at the moon, there are two major kinds of terrain you can see by eye. There are the dark gray mare, the huge plains of cooled lava. In the past, people thought they kind of looked like calm bodies of water, so they were named mare, the Latin word for sea. You can also see a lighter gray area that's almost white. These are the highlands. It was generally thought that the highlands were older than the mare, and it was hoped that by exploring them, we could find older rocks, which might reveal more about the formation and history of the moon. The Fraumauer Highlands are an area of heavily cratered, elevated terrain north of the Mare Cogito, the known sea, in the Oceanus Procellarum, the ocean of storms. That's where Apollo 12 landed. and it's south of the Mare Imbrium, the Sea of Rains. The Mare Imbrium is a huge impact crater on the near side of the moon, and its circular shape is obvious even by eye. The Imbrium impact is an important marker in lunar history because it appears the Imbrium was one of the latest Mare to form. One of the ways to gauge the age of things on the moon is to look at the number and size of craters within the feature. When things impact the moon, they essentially erase anything that was there before. So if we see a smaller crater inside a larger one, we know that the smaller one formed later. Imbrium appears to basically be on top of the other Mare, so it must have formed later. That collision must have been huge and thrown a tremendous amount of material up off the surface. This ejected material, called ejecta, would have fallen back down onto the surface. And it was thought that Frau Maro was some of the ejecta from the Imbrium impact. All right, so why do we want to explore the ejecta from craters? This is a picture of Meteor Crater in Arizona, and it's a pretty good example of why we find craters interesting to explore. First, you can see on the left hand side of the picture, you can see the exposed bedrock. The meteor kind of is a huge drill. It blasts this hole down into the bedrock, and we can see what's underneath the surface. You can see the linear strata on the left hand side of the picture. On the right hand side, you can see the crater rim up close. And you can see that those layers aren't level anymore. They're actually tilted upwards. And if you look really closely at those, you can see that on the lowest part of those layers, there's this very tan rock. And as you move up along the rim, you reach a redder, ruddy rock. And then right at the top, just at the edge of the photo, you can see that tan rock coming in again. Not only have the layers been pushed up, they've actually been bent back on themselves. And when you get to the rim of this crater, you can actually reach rocks, those tan rocks that came from much further down below. So if you can get to the rim of a crater, you can actually reach things you couldn't normally reach because of that overturned flap of stone. So you can also tell in that photo that you can see people in the photo up there on the rocks. So those rocks are also huge. So when this meteor crashed into Arizona, well, it blew a ton of stuff into the sky. And some of those were huge boulders, and a lot of it was tiny gravel. Well, the tiny gravel traveled a long way, but the boulders don't travel as far. So if you're at the rim of a crater and you find a huge boulder, you can be pretty sure that boulder came from that spot. And it probably came from way down below you. So we would be able to learn something about the interior of the moon that we just otherwise couldn't reach. So craters are really important exploration spots. And Frau Maro is a really interesting choice for geologists. It looks like it's ejecta from the Imbrium impact, so it might reveal some stuff about the deep interior of the moon. And it's also itself covered in craters. So if you could get close to one of those, you might be able to find rock that's been churned up by these subsequent impacts. On the left hand side, you can see a picture, you can get a wider feel for what the Frau Maro region looks like up close. And on the right hand side is a close up of where Apollo 13 intends to land. That crater in the upper right is called Cone Crater. It's about 1,000 feet across, and it's one of the major scientific goals for Apollo 13 to land there and reach its rim. And the three men who were going to go on this mission were Jim Lovell, Jack Swigert, and Fred Hayes, whose name apparently I'm kind of cutting off up here. Now, of these three guys, Jack Swigert is kind of the odd man out. He's not supposed to be on this mission. But in the last few days before the Apollo 13 launch, the backup lunar module pilot, Charlie Duke, developed a case of German measles. Measles is a really infectious disease. And during the incubation period, Duke probably would have exposed everybody on the prime and backup crews for Apollo 13. The doctors were pretty sure that Lovell and Hayes were immune to the disease given their medical histories, and they never developed symptoms. But they couldn't say the same thing about command module pilot Ken Mattingly. If Mattingly were infected with the measles, he would likely start getting very sick in orbit around the moon, and it would have been an extremely dangerous situation. So NASA managers made the decision to switch Mattingly with the backup pilot, Jack Swigert. The news was absolutely crushing to Mattingly, who ultimately learned about the final decision on the radio, and it sent him into a pretty deep depression. On the other hand, Jack Swigert had to be brought up to speed working with this new crew really quickly. But in many ways, the story of Apollo 13 is really Jim Lovell's story. By the flight of Apollo 13, Lovell was already one of the most experienced and storied astronauts in the world. He had flown twice in the Gemini program, and he had already flown to the moon once on Apollo 8. He was going to become the first person to fly to the moon twice. And he was finally going to accomplish his goal of walking on the moon. Even before the flight, Lovell had decided that Apollo 13 was going to be his final space flight. After all, how could you possibly follow up walking on the moon? Apollo 13 launched from Kennedy Space Center on April 11th, 1970, under good conditions. There were no lightning strikes like there had been with Apollo 12. Just about 2 hours later, the Saturn rocket third stage reignited and accelerated Apollo 13 on a trajectory to the moon. Swigert maneuvered the Apollo 13 command service module, named Odyssey, into docking with the lunar module Aquarius and extracted it from the third stage of the Saturn rocket. Apollo 13 was performing exactly as expected. About 30 hours into the flight, the crew performed a mid course correction to put Apollo 13 on a modified trajectory called a hybrid trajectory to prepare it to get into the right orbit around the moon to reach its landing site in Frau Mare. About 55 hours into the broadcast, or 55 hours into the flight, the Apollo 13 crew had a broadcast. They broadcast a television program from inside the spaceship. None of the television networks carried it because just after just 2 moon landings, the networks had decided that their audiences didn't really have the appetite for any more broadcasts from space. That was going to change. About 6.5 minutes after the conclusion of the television program that no one saw, about 56 hours after launch, Apollo 13 was about 210,000 miles from Earth. Earlier in the flight, a pressure gauge in one of the oxygen tanks had appeared to be malfunctioning. Mission Control asked the crew to stir the oxygen tanks. In space, supercooled liquid oxygen would stratify, it would actually separate out into layers, and it could cause the sensors to get erroneous readings. So, about once a day, the crew would turn on a fan inside the tank and actually mix everything back up. About 95 seconds after Swigert activated the fan, the astronauts heard what they said was a, quote, pretty loud bang, followed by wild readings about the electrical system. And the attitude control system on the ship, the thrusters, actually started firing, trying to keep the ship oriented right. The whole craft was shaking. Communication and telemetry was lost totally for about 2 seconds. 26 seconds later, Swigert reported, "Okay, Houston, we've had a problem here," followed immediately by Lovell confirming, "Houston, we've had a problem," and then beginning to report the laundry list of problems that Odyssey was now screaming at them about. NASA accident investigators eventually determined that this is likely what happened in those frenetic seconds. Almost 2 years before the flight, the oxygen tank that would become oxygen tank number 2 on Apollo 13 was dropped about 5 centimeters, about 2 inches. And though this little drop, there's very little risk of damage from it, it's possible that this damaged the drain line from the tank. Later in prep for Apollo 13, the tank was filled with oxygen and left to empty on its own, only it wasn't able to empty all the way. So NASA used heaters that had been installed inside the tank to warm the oxygen up and boil it all off. There were thermometers inside the tank that were designed to prevent the temperature from inside going dangerously high. But the thermometers had been exposed to way too high in electrical voltage, and they failed, allowing the temperature in the tank to reach probably about 1,000 degrees Fahrenheit. That high temperature damaged the Teflon insulation on the wiring to the fan inside the tank. So when Swigert flipped the switch to stir the oxygen tank, the wires leading to the fan sparked, igniting the oxygen. This caused the dome on the tank to fail, and the oxygen began filling the service module. The oxygen alone probably would have been enough to do what happens next, but there were likely other combustion byproducts. And the rapid expansion blew an entire panel of the service module off the ship, striking the antenna in the process, which led to the loss in telemetry. The Apollo 13 crew captured these pictures of the damaged service module in the moments before they returned to Earth. So things are pretty bad. Oxygen tank 2 is gone. Oxygen tank 1 is falling rapidly. The electrical fuel cells have snapped shut, and Odyssey only has a couple hours of power left. And Lovell looks out the window and he can see why tank 1 is falling. It's venting out into space. And if all of that wasn't enough, there's a cloud of debris that's growing around the spacecraft, making it impossible for the astronauts to see individual stars that they needed to navigate the spacecraft. Everything is getting very bad very rapidly. So now the mission becomes, how do you get the crew home? And there's really only two options to come home. There's the direct abort option. That means you turn your craft around, you fire the engines for all you got, and you come straight home. It's the fastest, it's the most intuitive. But the service module has been damaged. And it's possible that the SPS, the service propulsion system, that big engine on the back of the Apollo spacecraft, that might be damaged too. And even if it's not damaged, the engine is going to need electricity to fire and maintain the craft's orientation. And they are running dangerously low on electricity. Okay, but there's another option, a safer option called free return. On a free return trajectory, a spacecraft flying to the moon would actually swing around the backside, and lunar gravity would redirect the craft back to Earth. Even if the ship did nothing, gravity alone would ensure that Apollo 13 would come back to Earth. It would take longer, but the crew could use the lunar module Aquarius as a lifeboat, and NASA believed they could make it. Only Apollo 13 wasn't on a free return trajectory. It had deviated from that course earlier so that it could get into the proper orbit for its landing site. So Apollo 13 was going to need to use the descent engine on Aquarius to get Apollo 13 back on the right course. And Aquarius's guidance system wasn't designed for this. Very quickly, the guidance software on Aquarius had to be rewritten. But it worked, and Apollo 13 got back on the right course. The free return trajectory would take Apollo 13 back to Earth in about 4 days. But for about one more day, the crew would have to actually watch the Earth get smaller in the window as they approached the moon. And as Apollo 13 rounded the far side of the moon, it passed over the moon higher than any Apollo mission had or ever did. At the point of their closest approach to the moon, Apollo 13 was 248,655 miles away from Earth. This is the furthest any human has ever traveled from their home planet. Even though they didn't land on the moon, Apollo 13 did accomplish some science on its mission. Passing over the moon, they captured these photographs. And additionally, the third stage of the Saturn rocket that launched Apollo 13 to the moon was also directed to impact the moon. And that impact was recorded by the seismometer placed on the surface by Pete Conrad and Al Bean during Apollo 12. And this helped reveal some of the secrets about the moon's crust. Over the next 3 days, Apollo 13 drifted back to Earth. Aquarius also had to be shut down to conserve electricity. So the crew was stuck in a cold, cramped lunar module designed for 2 people. All the moisture in the air started to condense on the inside of the ship as the temperature fell. Carbon dioxide started to build up in the atmosphere of the ship, which led to the challenge of trying to fit the square command module filters into a slot designed for the cylindrical lunar module filters. But eventually, Apollo 13 did make it back to Earth. In the minutes before reentry, Apollo 13 jettisoned the damaged service module. And then after Odyssey was repowered, Aquarius was jettisoned to burn up in the atmosphere. And finally, Odyssey entered the atmosphere. was traveling faster than any Apollo capsule and at a shallower angle. As the hot gases built up around Odyssey, they blocked radio communication. On a typical Apollo mission from the moon, the blackout period would last for about 4 minutes. It took nearly 6 minutes for Apollo 13 to emerge from blackout. Apollo 13 splashed down in the Pacific Ocean on April 17th, 1970. Afterwards, the Apollo program was halted to figure out what had gone wrong. The accident investigation tracked down the failure and provided recommendations on how to improve the safety for future Apollo flights. But the accident scared NASA administrators and politicians, who were suddenly plagued by the idea that astronauts could die in space. And they began questioning, was it wise to continue sending people to the moon? Ultimately, the final flights of the planned Apollo program were cut short, and that was due in part to the public perception following the events of Apollo 13. But in the meantime, the mission goals for Apollo 13 weren't completed, and Frau Mare was still unexplored. So that would become the job of Apollo 14. Apollo 14 would essentially do what Apollo 13 had been prevented from doing, but it would do it under the much more intense scrutiny of having come just after the Apollo 13 accident investigation. The commander of Apollo 14 would be Alan Shepard, and he would be joined by Stu Rosa as command module pilot and Ed Mitchell as lunar module pilot. But the story of Apollo 14 is really the story of Al Shepard. On May 5th, 1961, Alan B. Shepard became the first American to enter space. His flight aboard the Mercury space capsule Freedom 7 reached an altitude of about 116 miles above the Earth, and it parachuted down into the Atlantic Ocean. Shepard's entire ballistic flight was over in about 15 minutes. Though it wasn't as impressive an achievement as the orbital flight of Soviet cosmonaut Yuri Gagarin just a few weeks earlier, the success of Shepard's flight was one of the driving factors in President John Kennedy's call just weeks later for the United States to commit itself to landing a man on the moon and returning him safely to the Earth. Only Al Shepard wasn't going to be a part of it. While training to command the first Gemini mission, Shepard experienced bouts of extreme vertigo. Doctors traced this to a buildup of fluid in the semicircular canals in the ear, a condition known as Meniere's disease. There's no cure for Meniere's disease, but it occasionally resolves on its own. Shepard was grounded because it was way too dangerous to have an astronaut who could suddenly become seriously disoriented. Like Mercury astronaut Deke Slayton before him, Shepard moved on into an administrative role as chief of the astronaut office. And even though Shepard might not fly on Apollo, he was going to select every crew who would. But Shepard hadn't really given up hope of flying again. In 1968, Shepard learned of a doctor in Los Angeles who says that he has a cure for Meniere's disease. The doctor suggests surgery to insert a tube into Shepard's ear and drain the fluid away. Shepard undergoes the surgery in secret, and it appears to resolve his condition. But there's actually no evidence that this works. The surgery doesn't appear to be medically sound. Even today, surgery is not recommended. There's still no cure for Meniere's disease. And I bring this up to illustrate how people like Al Shepard thought. They examined all the risks, they mitigated everything that they could until the risk was at an acceptable level, and then they embraced that risk. It's how someone could get on top of a Mercury Redstone rocket or climb inside an Apollo capsule after Apollo 13. As his last action as chief astronaut before returning to flight, he assigned himself as commander of Apollo 13. Other astronauts came to recognize that Shepard wasn't cutting in line. He had just simply been at the front of the line since he got at NASA. Still, NASA administrators weren't comfortable with Shepard flying so soon, and in a rare instance, they overruled that decision and moved Shepard and his crew to Apollo 14, They offered Apollo 13 to Jim Lovell and his crew. Apollo 14 launched from Kennedy Space Center on January 31st, 1971, but it didn't launch on time. Weather caused a delay of about 40 minutes. Apollo 14 wasn't starting off on a great foot, but it was about to get worse. After the third stage shut down from the translunar injection burn, the burn that boosted Apollo 14 on a course for the moon, it was time for Stu Rosa to get to work. Rosa needed to separate the command service module, Kitty Hawk, from the Saturn rocket, turn it around, and then dock with the lunar module, Antares. Rosa had been training for this maneuver more than any other astronaut in the program because of the pause to investigate the accident. He was sure that he was going to perform this maneuver using less fuel than any other astronaut. Rosa brought the craft together gently, and then they drifted apart. Maybe he hadn't brought them together hard enough, so he tried again. And again, they came apart. For some reason, the docking probe on Kitty Hawk wasn't retracting when it encountered Antares. And if Antares couldn't be extracted, and soon, there would be no lunar landing. Eventually, NASA controllers suggested bringing the craft together with the probe already retracted to see if it would engage the docking clamps. Fortunately, it did. Later, Shepards said that he was prepared to stick his arm out of the craft and literally hold the two ships together until the clamps engaged, if that's what it came to. Al Shepard wasn't going to let a little malfunction stop him from going to the moon. But the malfunctions sure would try. Days later, in orbit above the moon, Shepard and Mitchell aboard Antares were getting an abort signal. Only they hadn't pressed the abort button. For some reason, Antares thought the abort button was being pressed. Right now, in orbit, going through the checklist, the computer wasn't going to run the abort program. But if the computer thought the abort button had been pressed while they were trying to land on the moon, well, it would ruin the attempt and blast them away from the moon with no way for them to stop it. They had to figure out what was causing this. NASA thought that maybe a loose ball of solder was shorting out the contacts on the button. They asked Mitchell to tap on the panel. And when Mitchell did, the button turned off. Okay, so they had tracked down the source, but there was no way that they could open the panel up and fix it. Very quickly, NASA needed to figure out a way to reprogram Antares' guidance computer to lock out the abort button. And they did, in part, thanks to having to do something very similar to this on Apollo 13. On February 5th, 1971, 50 years ago tomorrow, Al Shepard and Ed Mitchell landed on the highlands of Frau Mare. Shepard landed closer to his target than any other Apollo landing. A few hours later, when Shepard descended to the surface, he said, "It's been a long way, but we're here," as he set foot on the moon, just the fifth person to do so. The astronauts then set to work, deploying scientific experiments that they had brought to Frau Mare. They discovered that Shepard had set Antares down with one foot in a small crater, so the entire ship kind of listed over to one side. This wasn't particularly dangerous, but it did make for very uncomfortable sleeping positions. The first of two EVAs, extravehicular activities, stayed mostly near Antares and the nearest craters. As these pictures go past, you can actually tell who is who in the pictures because NASA finally thought to add red stripes to the commander's spacesuit. Before this, both spacesuits looked pretty much the same. The second EVA was more focused on collecting rock samples, and the major goal was to reach the rim of Cone Crater. Cone Crater was the largest crater visited by any Apollo crew yet, and the geologists back on Earth wanted to learn all the secrets it might reveal. Shepard and Mitchell were surprised by the roughness of Frau Mare. They kind of expected it to be like a flat plain, but it was really hilly. And before the mission, they were confident they were going to be able to find their way. They were going to have overhead maps with images of the terrain. They were going to have a whole back room of lunar geologists directing them. And besides, they were pilots, not geologists. How hard could it be to find your way on the moon? Well, it turns out it's really hard to find your way on the moon. One of the ways your brain judges distance is to look at them through atmospheric extinction, even though you don't think about it. When you're looking at something very far away, that object looks paler, it looks more desaturated, and it looks a little fuzzier. Your brain notices this and understands those mountains are actually much further away. On the moon, there's no air, so your brain gets confused. Is that a small rock 100 yards away? Or is it huge and a mile away? It's very disorienting. Further, Frau Mare was really hilly and it was covered in all these small craters. It obscured any landmarks, even if Shepard and Mitchell could find them. They were lost looking for a 1,000-foot crater, and the geologists in the back room couldn't help them. Struggling to find the rim and running out of time, Mission Control told them to stop and consider where they were the rim of the crater. Once back on Earth, the geologists were able to use triangulation in the photos taken on the journey to figure out the exact path the astronauts had taken. They had gotten to within 65 feet of the rim, frustratingly close. Decades later, the Lunar Reconnaissance Orbiter was able to observe just how painfully close Shepard and Mitchell got to their goal before having to turn back. And the geologists were frustrated too. Apollo 14 brought back about 10 kilograms of rock, 9 kilograms in one single rock. The astronauts did a bad job of documenting their samples. On the moon, Mitchell said that one of the rocks would be easy to identify because it had a definite shape. The geologists were quick to point out that every rock has a definite shape. That's what makes them rocks. Back on Earth, Mitchell couldn't identify the rock he was talking about. The scientific shortcomings of Apollo 14 highlighted the need to send astronauts to the moon that were trained in geology and took an interest in the subject. Astronauts couldn't just be pilots anymore. The most famous thing to happen on Apollo 14 happened just before Shepard and Mitchell entered the lunar module to prepare to blast off the moon. Shepard turned on the color TV camera, turned towards it. The astronauts had set it up earlier, and he announced to Mission Control that he was holding a genuine 6-iron golf club. Shepard had smuggled aboard the head of a 6-iron and attached it to one of the geology tools. He had also smuggled aboard golf balls. Shepard proceeded to broadcast his golf swing to the world. It was difficult to swing given the rigidity of the spacesuit, and he was only able to grip the club with one hand. His first swing struck the moon and knocked the ball into a crater only a little ways away. His second connected, and Shepard announced that he had sent the ball for miles and miles and miles. It's a little point of human amusement on this other world. And I think it helps to remind us that these astronauts, they were people. They were regular human beings that dealt with regular human being things. They were trained test pilots and they thought about things in a different way, but they weren't superhuman. Sometimes they sliced the ball. And Apollo 13 and 14 were kind of the inflection point of the Apollo program. In some ways, Apollo 13 really brought about the end of the Apollo program by establishing just how dangerous space exploration was. And it really amplified the political reluctance to continue the program. If NASA kept sending people to the moon, somebody would die. And it would happen with the world watching. The Apollo and Saturn systems were incredibly complex machines where even dropping an empty tank 2 inches could lead to the death of 3 men. Never mind that the astronauts knew this and did it anyways. Who would want to be the person to sign off on the mission where astronauts died? Apollo 14 was really the last of the Apollo test flights. Shepard and Mitchell proved that Apollo could land in places of scientific interest. And the United States had done this 3 times. They landed and came back. Now that we could do it, What were we going to do with it? Apollo 14 showed that if we really wanted to do real science on the moon, we needed astronauts trained in geology. If we kept sending pilots like Shepard and Mitchell, we were going to keep getting random samples of rocks and regolith from the surface. And if that's all we're going to get, well, why don't we just send the robots instead? And these themes, they reverberate through the remaining missions through the Apollo program. So, looking forward, in July of this year, this will mark the 50th anniversary of the next mission, Apollo 15, landing at Hadley Rill in the lunar Apennine Mountains. Apollo 15 is the first truly science devoted missions. We're going to be doing some kind of event for Apollo 15, but we haven't really made a decision about what form that's going to take just yet. Hopefully, the public health environment will improve and we'll be able to invite all of you inside the Planetarium Theater again. All right. So that's going to bring us to the end of our program. I wanted to say thank you to everyone who joined us this evening. You can find us elsewhere online. You can find us on our website, delta.edu/planet. You can also find us right here on Facebook, facebook.com/Delta Planetarium. You can also check out our YouTube channel where we post new videos every week, youtube.com/C/Delta Planetarium. All right. And thank you and good evening.